Hey Math 3s, what's up? This is Sensei. How you doing? We're starting again a new section. And but we're going to be learning how to graph sine. Graph sine today, okay? It's totally new, completely new. You've never done this before in my class. I've never shown you how to do it. I don't think you've seen it before, so you better make sure you pay attention. Alright? But first, I'm going to show you how to get out there, protection from the coronavirus. Okay? Thing with the coronavirus, you need to wear a mask. Not only to protect you, but to protect everyone else from the germs of coronavirus. Make sure you apply the mask so, over your nose. Now my germs are not going towards you. The other thing with the coronavirus, when you're going out of the coronavirus, you got to protect your eyes from the sun. Sun rays. There you go. What do you guys think? Finally, we're doing the coronavirus. You got to keep your ears warm. Oh look, I got a hood. There you go. This is how you need to be out whenever you go to the coronavirus. I went out there, I got some toilet paper. It was great. So, we're going to be graphing sine today, okay? We're going to be starting to introduce something called the unit circle. But we're going to have four ways to represent our sine function. Represented as a graph, table, situation, and an equation. Okay? So, let's go ahead and get this thing going. You guys ready? Got some Fleetwood Mac for you, Angelita. You requested it. Here we go. Alright guys, let's do this thing. Let's rock and roll. Okay, so we're going to go ahead and start graphing sine here. So again, if you don't like my videos, go ahead and look up how to graph sine or graphing sine on YouTube. You can see other people and how they do it and stuff like that too. But I have this triangle here. Before we graph sine, let's go ahead and try to remember how to solve for sine, how to use sine as far as the right triangle goes. So here we go. Let's just review sine, right? Remember, use sine to find the missing length of a right triangle given an angle. Okay, so here we go. Here is my right triangle. All right, so let's say we have this right triangle here. And I asked you to solve for x. We have the 20, which is the hypotenuse, and we have the x, which is the opposite side. So you're thinking to yourself, hey, sensei, SOHCAHTOA. Okay? Now, I'm given this angle, I'm given the opposite side, and the hypotenuse. What do you need to solve for this, even though we already talked about it? Opposite hypotenuse will be sine. So we write our equation as sine 32 degrees equals the opposite side, which is x, over hypotenuse, which is 20. Okay, and then we go ahead and to solve for it, let's get the x by itself by multiplying by 20 on both sides. Both sides. And we say 20 times sine 32. This 20 goes away. We can use our calculator here. And we're going to say 20 times the sine of 32. Hit enter, and we get 10.59. If you can see that. So we'll say here x equals 10 point, we'll call it 60 for rounding up. That means this height right here is 10.6. Okay, now that's the basic stuff. You must know how to do that. In order, you have to calculate sine in order to know how to graph sine. So, that's a review. Now, how do we graph sine? So here's what we're going to look at here. We're going to look at the function of sine. We're going to look at it in our four different representations of a graph. Okay, so here are 4 representations of the graph, okay? We're going to do a situation. Okay, this will be our situation. I'll explain this later. We're going to look at our sine function as a table. And we'll look at our sine function as a graph. And, of course, we'll look at our sine function as an equation. So what's our situation going to be? Here's the situation. Think of this, okay? Our situation, imagine, if you will, that this is a Ferris wheel that spins around. Spins, 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 spins. And in each spin, the person is sitting right here, right? He goes around and he goes up here, spinning around, spin around, spin around. And let's say that this part right here of the Ferris wheel is the ground. The Ferris wheel is going to go underground. You must understand that. The Ferris wheel is going underground. The person sitting in a chair here, he's underground. Person sitting in the chair here, he's underground. The person sitting in the chair here, he's right on the ground. Right? Now let's say the radius of this Ferris wheel is 100 feet. So that's very high. Can you imagine being in a Ferris wheel that's 100 feet and it's spinning all the way up in the air and it goes below the ground? Okay, this is going to help us represent our sine function. Now I have this worksheet here for you that you can print. Okay, this will be our Ferris wheel. This is going to represent our sine function. Remember, this is underground, this is above ground. Okay, you can print this up and you can go ahead and copy it. Print it up right now and copy it, and then you can help you understand the sine function and how we graph it. But anyway, let's say that this is 100 feet. Right? From here to here. The radius is 100 feet. This is the ground. And let's measure these angles here. See the person sitting here. There's a little chair, he's sitting there. This person's sitting here. This person, there are all these chairs sitting on the Ferris wheel. Now, let's say that the Ferris wheel, all of these, like all the radiuses are the radii are the same. This is 100 feet. This is 100 feet. They're all 100 feet. Okay, I'm not going to label them all, but you understand that's 100 feet. Now, let's measure the angles of each one of these radii that goes to the chair. From the center, let's say that this one is 30 degrees. Okay? And then from here to here, I'm going to write now so we don't get confused. This one is raised at 45 degrees. And this one will be raised at 60 degrees. Now straight up and down, we got 90 degrees. Okay, and we just keep filling them in. Okay, after 90 degrees, we're going to increase another, this will be 120 degrees. This person sitting here, it's 120 degrees. This person sitting here, we'll say this is 135 degrees. This person sitting here is 150 degrees. Okay, don't worry about how I got these numbers, but they are a pattern. Some of you will start seeing this pattern. Don't worry about the pattern. 180 degrees. This is 210 degrees. Okay, and then we go here, another 15 degrees. This will be 225 degrees. This person sitting here. This person sitting here, right? So like all the way around, if I was open angle, that'd be 240 degrees. Going from here to here, this person here, this is 270 degrees right here, right? This person, now this person's underground, remember. Whoops. This person's underground. And how far underground is he? Well, he's 100 feet underground. Okay, now this person here will be 300 degrees. This person will be 315 degrees. This person will be 330 degrees. And this person will be all the way around, went 360 degrees, or we can say that is also 0 degrees. Okay? Now, this is our situation. Remember, we have 4 scenarios here. We're going to do a situation, we're going to do a table, we're going to graph it, and we have an equation. Now, the equation, well, think of this. Here's what we want to calculate. How high are each of these people in the Ferris wheel, given that we have a 100-foot radius? Okay? Now, how do we calculate that? Well, what we're going to do here, let's take this first person here at 30 degrees. Let's take the 30-degree person. How high is he off the ground, that the ground is right here? Okay? So look what I got here. I'm going to draw a little line to represent the height. There's the height right here. My height is going to be x. Do you see a right triangle there? So what I'm going to do here is I'm going to duplicate that right triangle. Hang on a second. Okay, so now here's a triangle that I drew. See this triangle? I just transposed it right there. How do I calculate the height? Well, look at this. There's a couple things we can do here. But I can say sine, right? If this is a right triangle, right? And using solving for the x for the right triangle, I can use sine. Okay, so let's say sine of 30 SOHCAHTOA equals opposite x over hypotenuse 100 feet. Okay, to solve for it, you multiply by 100 on both sides. And I say 100 times sine of 30 equals x. So let's go ahead and calculate. You guys see that there? Let's go and calculate that out. 100 times, whoops, let me clear that. 100 times sine 30, and that's going to equal 50 feet. By the way, some of you are able to calculate without a calculator because guess what? This is a 30, 60, 90 triangle. This is going to be half of that. But anyway, that's 50 feet. So my height, okay, at 30 degrees is going to be 50 feet. Let's put that in our table. Go ahead and copy this. I want you to make sure you copy this whole thing down, pause, and copy my form down there. Here, look, I'll hold it here so you can pause and copy that section. There's my situation in my table. Now pause and copy my graph and my equation. Okay, pause and copy that. Okay, so here we go. At 30 feet, I have a height, at 30 degrees, I have a height of 50 feet. Now let's calculate. I have 60 here, so we'll do 60 next, okay? So here's my 60. Let me draw the triangle. So here I have my 60. We could do 45, but on my table I only have 60. You can go ahead and calculate 45 if you want, but let's just calculate the 60. How high is this person at 60 degrees? Let's draw the height from the height down to here. Okay, how high is that? Well, let's draw the triangle and see. It's obviously going to be higher. Okay, so now here we go. This is 100 feet here, right? We're up here. Here's the guy. How high is he? There's my x. So we're going to set up our equation. We'll write it over here. Sine 60 of 60 equals x over 100. Okay, I multiply both sides by 100. And I calculate sine 60 times 100. $86.6. So this will be x equals 86.6 feet. Now another thing we can see, this is also a 30, 60, 90 triangle. And so if we have this, then we can figure out x will be 50, or 30, right? The 30 is half the hypotenuse. We talked about that last lesson. Make sure you understand that from last lesson. And this will actually be the 30 times the square root of 3, so this will be actually 50 times square root of 3, which will be 86.6. But don't worry about that. We're going to list it as 86.6 feet. Okay? 86.6 feet. So let's go to our table. We know it's 60. It's 86.6 feet. Okay? Let's move a little bit quicker here. What's my next table? Whoops, sorry, I wrote it there. Can you guys see that? 86.6 feet. Now, let's do 90. 90 feet is right here, right? Can't really make a right triangle out of that, but let's see if we can make a calculation. So, how high is this person right here? So 90 feet, how would we calculate that? How do you make a triangle with 90? You can't really, but the way we would write that is sine of 90 degrees equals x over 100. But can you deductively say how high this person is if the radius is 100? Can you see that? Well, he will be 100 feet, but let's go ahead and solve our equation here. Sine of 90 degrees equals x over 100 multiplied by 100. 100 times sine 90 equals x. Let's calculate that. 100 times sine 90. Let's see. It is 100, right? So we knew he was going to be 100 at 90 degrees. That person will be 100 feet. 100 feet. Okay, now, can you, based on your deductive reasoning, this person here at 120 degrees, how high can you predict that that person will be? Okay? Now, as you're thinking about that, I am going to actually draw a triangle that represents this situation here. Okay, I drew a little, I kind of traced over where this person is. Remember, you kind of see the circle in between. See, he's right here. He's right there, right? See the circle, the outline of the circle? See how I drew the angle of where he's at? There's 120 degrees right here. Now, how do we calculate that height? Well, if this is 120 degrees, and this whole thing is 180 degrees, guess what? I know that this angle right here has to be 60 degrees. And if I want to calculate the height, I can do it a couple of ways. The first way I want you to calculate this is, hey, this is just a right triangle. Let's look at this right triangle over here. I'm going to do it on this side over here. I can say sine of 60 equals, there's my height, opposite over hypotenuse 100, right? This is 100. And so you do 100 times sine 60 equals x, which we calculated before. We did this one before. We got 86.6 feet. Okay? So, and by the way, that should make sense, because I'm going to pull this side here, because guess what? This guy is at 86.6 feet, and you can see with your, I mean, if you could intuitively see that this is also going to be the same height at 120 degrees. He is the same height as this guy, which this guy's 60 degrees. This guy's 60 degrees over here. He is also 86.6 feet high, right? They're like mirrors of each other, those two right there. But what you must understand is we can also calculate this height. See, it's the same guy, 60 degrees here. Let me impose it over the circle so you can see. Another way we can calculate this is that, hey, this is 120 degrees. We could also calculate this as sine 120 degrees equals x over 100. Now go ahead and calculate that out. 100 times sine 120. Guess what we get? We also get 86.6 feet. So if you can see, if I'm calculating the height and I'm using this Ferris wheel circle, I can see that my height of sine 120 is going to be the same as sine 60. Okay? And you can see that on your calculator. If you just calculate the sine of 120, I get 0.866, and you calculate the sine of 60, you get the same answer because they're the same height. Okay? Now, using that deductive reasoning, if this is also, so I got 120 as 86.6 feet. Whoops, let's get to my table here. So let's fill out our table. Our 120 degrees is 86.6 feet. What about our 150 degrees? How high is that person? Well, if you look here, our 150 degrees is going to be the same height as our 30 degrees. And if you don't believe me, let's go ahead and calculate it. Sine 150 equals opposite over hypotenuse, right? Solving for the 150. So we'll go like, let's calculate it this way. I'll just do a little representation of the triangle here. Okay, so I have my triangle here. There it is. He went all the way 150 degrees, which means if this is 180, this is also 30 degrees from my 150. And if this is my x, I can calculate this sine 150 or sine 30. I'll get the same answer. You'll calculate that. You'll get x equals, this is 100 feet, equals 50 feet. Okay? Now, so that's 50 feet. So we could say 150. Sorry, let's get to our table here. 150 degrees. The guy is 50 feet high. Okay? Now, keep on going. You can fast forward this if you want, if you figured all this stuff out. But look, how high is this guy here at 180 degrees? Well, if you don't know, let's calculate. Sine of 180 equals the height over the hypotenuse. Multiply both sides by 100. But what is sine 180? Okay? You should see what the height is, but let's calculate. Sine 180 is equal to what? 0 times 100 is 0. So at 180 degrees, guess what we have here? We have 180 degrees. He is 0 feet. Okay? Now, what about 210 degrees? How high are they at 210 degrees? Okay, got our wheel here. Let's see, 210 degrees. Now, remember, this is the ground right here. So 210, we are now actually underground. Now I got a question for you. Can anyone, without me calculating, figure out how high this person, how far below ground, how many feet below ground this person is? Okay, go ahead and think about that, because you should be able to see it here, and I'll explain that in just a second, how you can figure that out. Okay, now remember, this guy right here, he is underground. Okay, so if I took this and I did the angle all the way around, that is going to be 210 degrees. The Ferris wheel spun around 210 degrees. Now remember, this right here is 180 degrees. So what's this measure angle going to be right here? Okay? Well, 180 minus 210 is actually going to be 30 degrees. Have we seen 30 degrees before? Yes, we have. So to calculate this, I'm going to show you two ways to calculate it. One is going to be the not so correct way, but I'm going to show you the fully correct way. Obviously, we have this, we're going to say sine of 30 equals opposite x over hypotenuse 100. But then I multiply both sides by 100, and I get sine 30 times 100 is actually going to be 50 feet. Now, this is not the fully correct. We had this before, by the way. We saw that 30 degrees was 50 feet. But the problem is he is not 50 feet above ground. He's 50 feet below ground. He is underground. So this is actually going to be a negative 50 feet. But we can't see that with 30. So let's calculate that with 210 degrees. So go ahead and try calculating that in your calculator. Sine 210 equals opposite over hypotenuse. Multiply both sides by 100. And let's calculate sine 210 times sine 210 times 100. What do we get? Notice it's negative 50. So when we use the 210 to calculate our height, it actually recognizes that we are going below ground. And we'll say x equals negative 50 feet. Okay? So we got that. So let's put that in our table. You put that in your table too. So at 210 we got now at negative 50 feet. And we can logically see that because he's below ground, or she's below ground, who's ever on the roller coaster. The next we got is 240. Okay? Now again 240. Let's go ahead and draw that picture, see if we can make sense of that. So I'm going to trace that. Okay, so now how low so now here he is in the circle, right? The Ferris went all the way, went to the ground, went underground. How low is this person? So let's think about what's going on here. Again, the Ferris wheel just spun. The Ferris wheel spun 240 degrees, right? If this is 180 degrees, 240 minus 180, that means right here is 60 degrees. There's our 60-degree triangle. And to solve it, we can say sine of 60 equals opposite x over hypotenuse 100. Multiply both sides by 100. And you should be able to predict. We already did sine 60 degrees, right? But we'll do it again anyway. Sine 60 times 100, and we get 86.6 feet again. But I ask you, x equals 86.6 feet. I ask you, what's wrong with this answer? He is not 86.6 feet in the air. He's actually below ground. So let's calculate the way it should be. Sine of 240 equals x over 100. Multiply both sides by 100, and you will see that 100 times sine 240, and we get negative, the negative 86. Now, you're going to start seeing a pattern here. I want you to start filling out the rest of the table. But here we go. I'm going to put in the negative 86.6 feet here at 240. 86.6 feet. Fill out the rest of the table on your own, and then we'll see if you get the same as me. Okay, so now I calculated the 270 degrees. 270 degrees should be easy because 270 degrees, guess what? He's right here, right? Or she's right there. That's directly below, the radius is 100 feet. That would be negative 100 feet below ground. I got the 30 degrees. Now 30 degrees is actually this, 300 degrees, sorry, is the same as the 240. Right? So that's the 86.6. And the 330 is the same as 210. So that's also going to be 50 feet. And there you go. There's our table. All right? That's the hardest part. Here's a full picture of the table. You should have all of those calculated using sine. Where they are on the Ferris wheel, how high they are, right? 30 degrees or 50 feet, 60 degrees or 86.6 feet, 90 degrees, 100 feet, 120 degrees, 86.6 feet, blah, 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 blah. Okay? You should be able to calculate all of those out. So anyway, everything we know about this coronavirus thing is, I can think of two things. One is like protecting yourself from others or protecting people from yourself, right? See, I can't give you any germs right now. So I'm protecting the mask, I'm protecting my eyes, right? Protecting my hair from the sun. And then also this, right? Where the heck are we going to get toilet paper? I just got some. Look at this. I got toilet paper. A Winco. In fact, I went to Winco looking like this, got the toilet paper. They just gave it to me. I didn't have to pay for it. Isn't that crazy? I don't know why. So, it's a long lesson, guys. We're already at 30 minutes. So let's go ahead and finish it up. Okay, so let's go ahead and graph our sine function. Okay, so basically, this y represents the height, and this x represents the degrees. Okay, this is my x and my y axis. So at 0 degrees, how high are you? At 0 degrees, we are 0 feet high, right? Look at our little picture here. 0 degrees, 0 feet high. At 30 degrees, how high are we? Well, 30 degrees, we are 50 feet. At 60 degrees, how high are we? Well, we are 86.6 feet. At 90 degrees, we're at 100 feet. And then at 120, what starts happening? We go back down to the 86.6 right here. And then at 150, we go back down to the 50 degrees. And then at the 180, remember we're back down on the ground, right? 180, we go all the way around, we're back down on the ground. And then at 210 degrees, we go below ground. We are now at below 50 feet. At 240, we are now at 86.6. At 270, now we're down to 100, right? At 270, we're down here, right? 270, we're all the way down here at 100 feet below. Okay? And then we get back at 300, we're back at 86.6. 330, we're back at 50. Sorry, right there, 50. And then 360, we're back on the ground again. And here's what our sine function is going to look like. Connect the dots. And it's a beautiful, beautiful wave. And guess what? As the circle keeps going round and round, we're going up and down, right? But that's the sine function. Of course, it's not the actual, that is technically what sine looks like. We use the representation of a Ferris wheel. Whoever said you're not going to use this in real life? So we have our 4 representations of our equation. We have the roller coaster, 4 representations of our function. Roller coaster, Ferris wheel, spinning around. We got the table. The degrees will tell us how high we are based on the Ferris wheel. And then finally, we have the graph where we can represent the height based on our degrees. And then finally our equation, which actually our equation is going to be y equals sine x. And this will be actually times 100, but we'll just leave it at this because that'll be our function. And that is how you graph sine. There it is. There's our 4 representations. Yours should look like that. Make sure you upload the circle that I'm gonna have there. Make sure you print it so you can get all this set up. But this is the basics of graphing sine. This is actually how to graph the actual sine for the unit circle. But this is a good representation, a good idea, right? So you get an idea. The more you go around, the circle goes up, and then you go back down, and then you go underground to the very bottom, and then you start going back up again to the ground. And it'll keep going up and down, up and down. It'll keep going and going and going. Okay? All right, guys, that's it. That's the whole lesson. That was a long one. Okay? So hopefully break it up into pieces, which by this point you've already seen it, but good luck. All right? It's important that you get this, though. Remember, this is an important concept you need to know for pre-calculus next year. All right? So good job, guys. Pause, replay. Leave comments if you have questions. I'll answer those questions. See me in my office hours. And subscribe. I got 100 subscribers. I broke 100. I can't believe it. That's right. All right. I'll see you guys later. This is Sensei signing off. 36-minute video. Woo!